machine learning-based emotion recognition system using EEG signals. In this short presentation, our goal is to offer you a quick summary of the research and conclusions. Please follow the links to review the research and further details. Many scientific studies have been concerned with building an automatic system to recognize emotions, and building such systems usually relies on brain signals. These studies have shown that brain signals can be used to classify many emotional states. This process is considered difficult, especially since the brain signals are not stable. Human emotions are generated as a result of reactions to different emotional states, which affect brain signals. Thus, the performance of emotion recognition systems by brain signals depends on the efficiency of the algorithms used to extract features, the feature selection algorithm, and the classification process. Recently, the study of electroencephalography, or EEG, signaling has received much attention due to the availability of several standard databases, especially since brain signal recording devices have become available in the market, including wireless ones at reasonable prices. This work aims to present an automated model for identifying emotions based on EEG signals. The proposed model focuses on creating an effective method that combines the basic stages of EEG signal handling and feature extraction. Different from previous studies, the main contribution of this work relies in using empirical mode decomposition / intrinsic mode functions, or EMD/IMF, and variational mode decomposition, or VMD, for signal processing purposes. The feature extraction step is to increase the accuracy of the classifiers through obtaining the most valuable features from the signals. This phase uses two types of feature extraction methods: entropy study, or SE, and Higuchi's fractal dimension, or HFD. Finally, in the classification stage, 4 classification methods were used: naive Bayes, K-nearest neighbor, or KNN, convolutional neural networks, CNN, and decision trees, DT, for classifying emotional states. Each classifier differs in its approach. The classes were processed and classified with the same data that has been cleaned, filtered, and featured. To evaluate the performance of our proposed model, experiments were applied to a common database called DEEP, based on many evaluation models, including accuracy, specificity, and sensitivity. 3 major sizes of testing and training data were used on this method to obtain the accuracy and runtime. After applying these classifiers under different criteria, each classifier yielded different results and running times, and these results were studied. It was concluded that the CNN classifier yielded the best results in terms of model performance. There are several differences in the performance of machine learning classifiers in terms of accuracy, precision, recall, and one measure. Throughout our tests, we found that the CNN was best in terms of accuracy. Results also showed that the results of NB and KNN were convergent. However, CNN outperformed other methods in EEG signal categorization when applying an F1 measure on various cases and different classifiers. CNN yielded the highest F1 measure in accuracy in all cases.